experiment number 1. What is the experiment? Determination of determination of strength of acid in lead acid battery. Determination of strength of acid in lead acid battery. For this titration, we have to take the aim of the experiment is to determine the strength of an acid present in the lead acid battery. So for this, we have just look at the your observations manuals. You will find the first one is the aim of the experiment to determine the strength of the acid present in the given sample, acid sample. Second one, apparatus or chemicals required. So here we will use burette, pipette, conical flask, then beakers and burette stand. These are the apparatus. Chemicals required are oxalic acid. We will use the very important chemicals like oxalic acid, NaOH solution. Then we have acidic sample and that is sulfuric acid sample. Next we have phenolphthalein indicator and methyl orange indicators. These are the chemicals that we use for the titration process. Next we go for the principle of the titration. In the principle of the titration, we will come to know that here there are some ions which are produced by the acid into the solution. Acid produces what ions into the solution? H plus ions into the solution. Here we have an acid called sulfuric acid. Lead acid battery is a battery which consists of sulfuric acid as electrolytic solution. In lead acid battery, in lead acid battery we have anodic part, cathodic part and electrolytic solution is present. Anodic part is lead. Okay, so cathodic part is lead dioxide. Cathodic part is lead dioxide and electrolytic solution is dilute sulfuric acid. Dilute sulfuric acid. This dilute sulfuric acid which will produce H plus ions into the solution. Lead acid battery is a secondary battery. Lead acid battery is a secondary battery. It is a rechargeable type of a battery. So here we will find the H plus ions that are produced by the sulfuric acid that is present in the lead acid battery, which is neutralized by the OH minus ions that is liberated by the sodium hydroxide solution. Sodium hydroxide solution produces OH minus ions into the solution. Therefore, H plus OH minus gives rise to H2O. This is a neutralization reaction. Understood? So you take this chemical reaction. This is a neutralization reaction. Example, I am taking H2SO4 plus NaOH gives rise to Na2SO4 plus H2O. This is a neutralization chemical reaction. Understood now? So this is a neutralization chemical reaction. So in this chemical reaction, acid plus base gives rise to salt plus water. This is a very important chemical reaction. Understood? Under the principle, we come to know that acid sample which is titrated with a sodium hydroxide. Acid sample is titrated with a sodium hydroxide by using an indicator called methyl orange indicator, and the end point of the titration is yellow color. End point of the titration is yellow color is the end point of the titration. So this is the titration process. Now let us go for the next important aspect. What is the procedure? In the procedure we will find the preparation of solutions. How to prepare these solutions in the laboratory. In the preparation of solutions, oxalic acid is a primary standard solution with a standard concentration of 0.1 normality. So it is a 0.1 normality containing standard oxalic acid is taken. It is prepared by accurately weighing 6.3 grams of the oxalic acid salt, which is to be dissolved in, so very importantly, 1000 ml of distilled water. This gives you what? Standard concentration of oxalic acid, which is what type of a standard solution? Primary standard solution. What is the primary standard solution? Oxalic acid is the primary standard solution. Now you take the formula of normality. Normality is given by weight by equivalent weight into 1000 by volume. Now what is the weight of the substance? 6.3. What is the gram equivalent weight of oxalic acid? 63 into 1000 by 1 liter volume, that is 1000 ml. And it will gives you 6.3 by 63. So therefore it gives you 0.1 normality. This is the concentration of our oxalic acid. This is the way to prepare primary standard solution. Next we have the second solution is called sodium hydroxide or NaOH solution. While preparing NaOH solution, approximately or accurately weighed 4 grams of the sodium hydroxide salt is to be dissolved in the 1 liter of the distilled water. It will become the very important sodium hydroxide solution. Okay. Next we have phenolphthalein indicator. It is the indicator that is to be prepared by taking 1 gram of the phenolphthalein powder, which is to be dissolved in 100 ml of ethyl alcohol. And the methyl orange indicator is prepared in the same way. 1 gram of methyl orange indicator powder has to be dissolved in 100 ml of ethyl alcohol. So this is the method of preparation. After preparation, then we will go for the last one. That is called acid sample. What is the acid sample? Which is unknown. We need to find out. So the concentration we need to calculate. So let us go for the titration process now. If you go to the titration process, so here we have the procedure that includes titration. The first step of the titration is called standardization of NaOH. The first step is the standardization of NaOH solution. Understood now? So the first step is the standardization of NaOH solution. For this titration, how to execute? Let me tell you first. First, take all the glass apparatus, clean and rinse all the glass apparatus with the tap water, and then rinse it with the distilled water. Then take a sodium hydroxide solution, fill the burette using the sodium hydroxide solution. Take a burette, fill the burette using the sodium hydroxide solution and fix it to the burette stand. It is to be fixed to the burette stand. So this is the first step. Then after, take a clean conical flask. So you just see the procedure. Next, take a clean conical flask of 250 ml volume. Transfer about 20 ml of standard oxalic acid into it. About standard oxalic acid of how much volume? 20 ml volume is transferred into the conical flask by using a pipette. So therefore, to this add about 1 to 2 drops of the phenolphthalein indicator. So 1 to 2 drops of the phenolphthalein indicator. After addition of phenolphthalein indicator, the conical flask solution is taken and it is now titrated with the burette NaOH solution. So we will get the end point where the color turns from colorless into pale pink color. This is the end point of the titration. So once you got the end point of the titration, stop the titration and note down the volume of NaOH consumed for the titration 1. So this is the first step of the titration. How it is to be done? Let me tell you once again. First take all the glass apparatus, clean and rinse all the glass apparatus. Then take a burette, fill the burette using sodium hydroxide solution. Then take a conical flask of 250 ml volume, transfer or pipette out about 20 ml volume of oxalic acid, which is the primary standard solution. To this add 1 to 2 drops of the phenolphthalein indicator, then followed by titration up to we will get end point where the color turns from colorless into pale pink color. Once you got the end point, stop the titration. Note down the volume of NaOH consumed for titration 1. So this is the titration which is to be performed for about concurrent values to be obtained. Okay, this is the first step. Now first step is completed. Let us go for the second step of the titration. What is the second step of the titration? Yes, it is called standardization of acid sample. What is the second step? Standardization of acid sample. So in the second step, that is called acid sample, we know very well. Again, we have to refill the burette using standard NaOH solution. Now the burette solution is called as what solution? It is called standard NaOH solution. Now it is called as standard NaOH solution. Now the concentration of this solution is known to us. In the first step it is already known to us. So from the first step we got the concentration of NaOH solution. Hence it is called standard NaOH. What type of standard it is? Secondary standard. What is the primary standard? Oxalic acid. What is the secondary standard?
Standard
Standard NaOH solution. After refilling the burette using standard NaOH solution up to the 0 level mark without any air bubbles and parallax error, fix it to the burette stand. Then after, take a clean conical flask of 250 ml volume. In this now, pipette out or transfer about 20 ml of acid sample. You see, what is the sample that we are taking in conical flask? Acid sample. So now 20 ml of acid sample is transferred by using a pipette. To this, add 1 to 2 drops of the methyl orange indicator. We are adding, what is the indicator? 1 to 2 drops of the methyl orange indicator is added. After addition of methyl orange indicator, take the conical flask solution. Immediately it is titrated with the standard NaOH solution until we will get end point where the color turns from orange red into yellow color. Orange red into yellow. What is the end point of the titration mark? Yellow color. Orange red into yellow color is the end point of the titration. Once you got end point of the titration, stop the titration. Note down the volume of NaOH, standard NaOH consumed for titration 2. Okay, this is the second step. So what is the second step? Let me explain you once again. Take the burette, refill the burette using standard NaOH solution up to the 0 level mark without any air bubbles and parallax error. Then take a clean conical flask of 250 ml volume. In this, transfer or pipette out about 20 ml of acidic sample. After that, to this, add 1 to 2 drops of the methyl orange indicator. After adding methyl orange indicator, take the solution and it is titrated with a burette NaOH solution until we will get end point where the color turns to yellow color. Once you got the end point, stop the titration. Note down the volume of standard NaOH solution consumed for titration 2. Okay, this is the second step. From these 2 steps, we can determine the concentration of our acid sample by using the formula N1V1 is equal to N2V2. So based on this calculation part, we will get the concentration of NaOH. Understood? So that is a very important step. Okay.